Okay, so this is section 9.1, using matrices. At the end of this screencast, you'll be able to apply addition, subtraction, multiplication of two matrices, and scalar multiplication to real-life situations. So our first example here consists of a basketball team. So we've got the various players, and these are the rows, and then the number of 3-pointers, 2-pointers, and 1-pointers that they've shot during a particular game. Part A, write matrix P to represent the three different scores that are possible. And it refers to it as being a column matrix. We're not going to put it as a row, we've got to put it as a column. So we can, with the 3-pointers, it's worth 3 points. With a 2-point shot, it's worth 2 points. And with a foul shot, it's worth 1 point. So there, that is our column matrix P. B, write a matrix G to represent the data from the table. So we've got the various players, they're the rows, and then the number of each type of shot that they've made. So we've got G, players running this way, and then the number of each type going through. So as an example, this element here, where we've got a 2, would represent player Daisy making 2 2-pointers. C, use matrix multiplication to find a score matrix named S that represents the total scored by each player. So we've got to think about the dimensions of the two matrices that we've got. So we've got matrix G, which gives us all the game data, and then we've got matrix P, which gives us the value of each type of shot. Now matrix P is a column matrix, so it's 3 rows by 1 column. Matrix G is the game data, and so there's 7 rows of players and then 3 rows that tell us how many of each type of shot that they've made in the game. So it's a 7 by 3 matrix. So the only way that we can do a multiplication here is to do matrix G by matrix P. The reason being is that the two inners need to be the same, and furthermore the resultant matrix, or the answer matrix, will be a 7 by 1 matrix. So when we do that, you can see we've got matrix G here, again the 7 players and the number of each type of shot that they've made, and then we multiply it by the P matrix, which tells us the how many points each type of shot is worth. So if we do that matrix multiplication, of course we'd do that on our CAS, we wouldn't be expected to do that by hand, we'd get this matrix here. And so you can see the total number of points that each player has made in that game. So how do we get a value of 10 for Joe? Well, the position of this is 1, 1. So that's found by taking the first row by the first column. So 0 times 3 plus 5 times 2 plus 0 times 1. And if you add that together, you'll get your 10. If we look along here for, let's say we select Bill. So Bill scored 17 points. So Bill is 1, 2, 3, 4, 5. He's the 5th row, so he's position 5, 1. So if we go along to the 5th row, 1, 2, 3, 4, 5, then it's going to be 1 times 3 plus 2 times 7, or 7 times 2, plus 0 times 1. So we just go through in that order, and that will add up to that 17 points. You can see Daniel scored the highest, and so that is position 7, 1. So that's found by doing the 7th row by first column. So it's 1 times 3 plus 8 times 2 plus 1 times 0, or 0 times 1. Okay, so they are the individual scores for each player. D, which player won the best award? So the assumption here is that the person who scored the highest in the game would be receiving the best player award. And so you can see that Daniel scored the highest number of points, so he gets the award. E, the opposition team scored a total of 87 points. Did the basketball team win the game? So to work out how many points the entire team scored, we just have to add these together. So 10, 11, 14, 16, 17, 6, 19. And if we did that, it adds up to 93. So of course the Wolves, the basketball team, outscored the opposition, so 93 versus 87, so the Wolves won. Okay, so this second example here looks at a local hardware store, and the first little table here shows the number of purchases that the hardware store has made. So they, of course, they make purchases to bring in stock, which they can then sell on to their customers. So we've got a small metal fastener and a large metal fastener, and they're obviously the rows. And then we've got week 1 and week 2. The figures here tell us how much of each type that they've actually purchased. Each small metal fastener costs $3 to buy, and each large one costs the hardware store $5 to purchase or to buy. A. Find 2 matrices that can be multiplied to give the total purchase cost of metal fasteners in each of the 2 weeks and complete the multiplication. So here we've got the purchasing matrix, and that is a 2 by 2 matrix, 2 rows by 2 columns. We then have the cost of each of the fasteners, and this is a 2 by 1 matrix. Now think about it. What we want to achieve here is to have 121 being multiplied by 3 because each fastener costs the hardware store $3. And then we want to add to it 112 multiplied by 5 because each large fastener costs the hardware store $5 to purchase. So if we look at the way that these 2 matrices have been set up, this 923 here will represent the total cost to the hardware store of purchasing fasteners in week 1. So how is that 923 formed? It's the first row by the first column. So 121 times 3 plus 112 times 5. And that gives us the 923. The 705 figure. So in the second week, the hardware store has had to outlay $705 to purchase fasteners. So that's 95 times 3 to give us the cost for small fasteners, plus 84 times 5, which is the cost of the large fasteners. Altogether, that's $705 for the week. So if we think about it logically like that, we can get the multiplication set up correctly. Please note that this here is a 2 by 2, that's a 2 by 1, so I couldn't have the 3, 5 listed first. The 2 inners need to be the same, and the answer matrix or the resultant matrix will be the dimensions of the 2 outers. So this is a 2 by 2, that's a 2 by 1, so the 2 inners are 2s, and the outers are a 2 and a 1, so the answer matrix will be a 2 by 1, and that will give us the total amount that we have had to purchase or spend for each of the 2 weeks. Week 1 total, 923, week 2, 705. Here we have another table that shows week 1, week 2, so this is now listed as columns, and then each of the different products that we have, so paint, timber, metal fasteners, gardening tools. So obviously what we need to do here is include those figures that we just found. So week 1, we spent a total of 923, so that would go in here. And in week 2, we spent a total of 705, so that will go here. Represent these costs in a 4 by 2 cost matrix called C. So this is our cost matrix overall, and you can see that's where the 923 comes in and the 705. Now what's told up here is that the manager sells these goods. So he brings in the products into his store, but then he marks it up by 55% and sells that to the customers. So this is the cost of the hardware store, but it's not the selling price to the customers. Use scalar multiplication to represent a selling price of these goods. So the selling price, matrix S, will be 1.55 multiplied by the cost. Now that 1.55 just represents an increase of 55%. So an increase of 55%, if there was no change, we'll just simply multiply the cost matrix by 1. But we've got a 55% increase, so 55% as a decimal is equivalent to 0.55, so we need to multiply it by 1.55. So it's just a basic scalar multiplication. 1.55 times matrix C, that was worked out in the previous bit, gives us this matrix here, matrix S, which tells us the selling price to the customers. create a profit matrix. So our profit is always going to be the selling price minus what it cost us to purchase those goods. So it's the selling price to the customer minus the cost of buying the product. So it's simply going to be matrix S minus matrix C. So you can see here it's all shown by hand, but you can just easily do copy and paste on your CAS calculator to get there. And so this is the profit. Calculate the total profit to be made if all the goods purchased over these 2 weeks were sold. So we bought all those fasteners and paint and timber at the beginning of the 2 weeks or during the 2 weeks. So if we assume that everything that we purchase does get sold, what will the total profit be? So what we need to do is add up every element within the profit matrix. So we're just adding all of these together. Remember, that's week 1, that's week 2. So you can see here that in this third row, this represents the fasteners. So we made a clear profit, or the hardware store made a clear profit of $507.65 in week 1. And in week 2, they made a clear profit of $387.75 just for the fasteners. These were the timber off memory and paint, and I can't remember what the last one was, but they are the various items for week 1, week 2, clear profit they have made. Okay, looking at example 3 here, this is a bird watching situation. So what this matrix be, and we've got individuals, and then the number of sightings that they've made for 3 particular types of birds. So flitters, bitwings, and redwits. So as an example, this 10 represents that Gordon has seen a redwit on 10 occasions. And this number 3 represents that Harry has seen a bitwing type of bird on 3 occasions. All right, we've got matrix P, which is a row matrix consisting of 4 ones. And we've got matrix Q, which is a column matrix consisting of 3 ones. So in this example, what you're going to see is how we can do some summing and some averaging, making use of the general information and then the summing rows and matrices. So in A, we need to calculate the product of PB. So matrix A is going to equal to PB. So here's matrix P, and then we've got matrix B. So the information matrix is going to be pre-multiplied by this P matrix. So there's a setup, and that will form A. So this 21, how was that calculated? Well, it's the position 1, 1, so it's the first row by first column. So it's 1 times 13 plus 1 times 2 plus 1 times 1 plus 1 times 5. Adding all of those together, and you'll get 21. So in effect, what it's really doing is just adding up that column is 21. And adding this column together will give us 16, and finally 19. So of course we could just do that manually, but using matrices makes things a lot more efficient. So what it's actually provided us with is that A gives the totals for each type of bird sighted by the club members. So there were 21 of the F type of bird, 16 of the B type, and 19 times the redwit bird has been seen. What information does A13 provide us with? So row 1, column 3. So if we go back to matrix A, there you can see we've got a 19, and that tells us that on 19 occasions the redwit was seen by club members. This time we've got matrix C, and that's equal to BQ. So here's our information matrix B, and now we've got the summing column matrix. And you can see that to get this 22, that position there is row 4, column 1. So row 4, column 1, it's 5 times 1 plus 7 times 1 plus 10 times 1. And for that, you'll get a 22. So when we set it up in this way, the information matrix being post multiplied by a summing column, then what that will do is add up each of the rows. So this 22 represents the total sightings that person G has made. So each of these rows is added. What information does C21 provide us with? So second row, first column, so it's that 9. On 9 occasions, person E has sighted some type of bird. Her name's Esfa. C, calculate a quarter of PBQ. Now we recognise that BQ is in fact column C, so we did that earlier. So there's BQ there, that's in fact column C. So that column C gives us the total number of sightings each person has made. Column P is, sorry, not column P, matrix P is this row matrix here. And then we've got a quarter, a scalar out the front. So what that matrix times this matrix, so this here is a 1 by 4 being multiplied by 4 by 1. So it is possible to do the matrix multiplication because the two inners are the same. But the answer matrix for this will be a 1 by 1, so just give us one large number. So what's happening here is that multiplication is simply adding that column together. Now we've got a quarter out the front of here. So if we're adding the total number of sightings that all club members have made together, and then we're multiplying by a quarter, so in other words we're dividing it by 4, what we're really doing is working out the average number of sightings each person has made. There are 4 people. In total, we have however many sightings, the addition of this column here. We then take that answer and divide it by 4, we'll have the average. So just showing that matrix multiplication, if we add that column together, we'll get 56. So in total, there have been 56 club sightings. And then we multiply it by a quarter to give us 14. So on average, each member has seen a bird on 14 occasions. And that's summarised there.